Okay, this is the first video reviewing what we covered in this unit. And so if you think about day one, it's not a lot to say here. A lot of it was just kind of practicing some mechanics, but the beginning was just talking about the different types of numbers. So breaking down real numbers, irrationals, rationals. And that has come into play a little bit so far when we talk about, you maybe remember when we talk about the discriminant, if the discriminant, which is what's under the square root in the quadratic formula, if b squared minus 4ac is not only greater than 0, but also a perfect square, we say there are two distinct rational roots. So just getting used to the language of rational versus irrational. And that's how we started off. So not a ton to say there. We really got into things when in the second day, when we talked about inequalities. And in the past, probably most of your inequality work dealt with linear inequalities. And what I mean by that is maybe the highest degree that you had an inequality was x to the first power. So if I were solving something like this, I would just isolate x. And really the main thing I had to, well, it helps if I can add correctly. It's negative 8x. The biggest thing I had to worry about there was when I multiply it by or divide by a negative, I have to flip that inequality sign. So this would be x is greater than negative 5/8. And in interval notation, that would be negative 5/8 to infinity. But that's not the case when we get to x being a higher power in an inequality. And so we started by talking about some quadratic inequalities, and then we did higher order inequalities. But the gist of it, and we did rational inequalities, meaning variables in the numerator and denominator. But if x is not just of degree 1, like you don't have a linear inequality, you always want to bring it to one side, put it in factored form, and do sign analysis. So let's do an example. Do two types. Let's do one. Actually, this is something people had trouble with. So let's do x plus 2. I'm going to make it simpler than before. Maybe 3x minus 7 greater than or equal to x plus 2 and maybe 2x plus 1. Okay, so the tendency always is to just cancel out that x plus 2. It would make life so much easier. The problem is you're going to be losing solutions here if you do that. So instead, and if I were to FOIL out, notice I don't have x to the first as the highest power. I'm actually dealing with a quadratic here. So when you notice that, avoid the temptation and go back to inequalities now. We're bringing everything to one side and factoring. So I'm going to bring everything to one side. Minus x plus 2, 2x plus 1. And I notice here that, okay, I just have two groups of numbers separated by subtraction. And remember when factoring, the first thing you always want to do is there a GCF that I can factor out? Because that may make my life easier if there is. And in this case, yes, both of these have a common factor of x plus 2. So I'm going to factor that out. And remember, factoring out means dividing out. So when I factor it out of the first grouping, I'm left with 3x minus 7. And when I factor it out of the second grouping, I'm left with this 2x plus 1. Now, I feel like that piece confuses people a little bit. Like, how the heck did I put these things together? So sometimes I find it helpful to think of something simpler. Like, say I had AB minus AC greater than or equal to 0. When I factor out the A, what am I left with? B minus C. Same deal here. You can think of this as my B minus my C. And that's just what I'm putting there. So I feel like a good go-to whenever in doubt is try to make something similar and then strategize, simpler, not similar, simpler, and strategize how would you approach that. Okay, so almost done. So I've got x plus 2. And then let's combine like terms. I've got x minus 8. All right, now I'm in fully factored form. All I did here, by the way, is distribute this negative and then combine like terms. All right, so you can't just say, and the reason we have to do sign analysis, this does not mean that x plus 2 is greater than or equal 0 and x minus 8 is greater than or equal to 0, and this solve those individually. They're interacting with each other. They're both positive, you'll get a positive solution. If they're opposite in sign, you'd get a negative, and if they're both negative, you get a positive. So you have to deal with the fact that they're interacting with each other. Okay, so we've got 8. And by the way, I find it very helpful to not just put numbers on my number line, but if I see that we're talking about equality here as well, I'm going to fill in those circles so that I remember not to forget those. Those will be hard brackets. Okay, if I put in a value greater than 8, I'm positive. And I notice that all of these parentheses, or my factors, are raised to an exponent of 1. Meaning on either side, as I go across 8, this is going to change sign. When I'm above 8, it's positive. When I'm less than 8, it's negative. And if one thing changes sign in this product, the whole thing changes sign. So that's why across 8, I'm going to change sign. We say alternating signs. And then I go to negative 2. Negative 2 as well came from something to the first power. So to the right of 2, it's going to be a different sign. Sorry, to the right of negative 2, it's going to be a different sign than to the left of negative 2. So it's going to switch signs across negative 2. All right, so I've got my sign analysis, and now let's answer the question. I want greater than or equal to 0. So I'm going to say my solution will be negative infinity to negative 2 inclusive, union 8 to infinity. Okay, so that was an inequality where it ended up being actually a quadratic inequality, but it started off looking rather odd. Let's do one that has variables in a denominator as well. So what if I gave you this? What if I said, again, solve this inequality, and I can't promise this is going to turn out nice, but we'll see. 2 over x minus 2 greater than or equal to, let's see, let's just 3x plus 1. So the temptation here might be to multiply both sides by x minus 2 and x plus 1, or clear the denominators, in other words, but you can't do that because I don't know if x minus 2 is positive or negative, so I can't multiply both sides by it because if it were negative, I'd have to flip the inequality sign, and if it were positive, I wouldn't. So instead, excuse me, just like before, when you see this clearly not a simple linear inequality, bring everything to one side and let's try to get this in some sort of factored form so I can do sign analysis. Okay, so in order to get it in factored form, right now I have 2 fractions, so let's make it a single fraction, which is going to be x minus 2 x plus 1 as that common denominator. This, of course, needs to be multiplied by x plus 1 over x plus 1. And this here needs to be multiplied by x minus 2 over x minus 2. So that means my numerator, if we have this common denominator, my numerator is going to be 2 times x plus 1 minus 3 times x minus 2. And let's just distribute the numerator and combine like terms. So 2x plus 2 minus 3x plus 6 over my x minus 2, x plus 1, greater than or equal to 0. So I'm going to get negative x plus 8 over x minus 2, x plus 1. Perfect. It's in factored form. All right. I mean, if it makes you feel better, you can do this in the numerator to make it look factored. All right, so put on your sign chart. both where the numerator and denominator equals 0. These are all interacting together. The numerator equals 0 actually at 8, because if you set negative x plus 8 equal to 0, you'll get 8. And make sure you fill that in. Because where it equals 0 matters. And then I'm going to put in 2 and 1, but those need to be open circles because you can't divide by 0. So those would not be included in our solution. And now let's just put, notice again, they're all to exponent of 1 or multiplicity 1, so it should alternate signs. So if I put in a value greater than 8, let's do this. So if I put in something greater than 8, then it looks like I am going to, because the numerator, if I put in 9, for example, would be negative, but the other two would be positive. So it's looking like it's negative. And then I just said it's going to alternate signs across because everything's raised to an odd exponent. This one's a little bit weird, so maybe I'll just double check by testing if I put in 0. If I put in 0, I'm looking at this and it looks like, oh, I know why. This is -1, sorry. If I put in 0, which is in between the two, I am going to get 8 over -2 times 1, which is indeed negative. So that just makes me feel better that I did this. Okay, and now let's just answer the question. Greater than or equal to 0, that's what I'm looking for. So -infinity to -1 with a parentheses, union 2 with a parentheses to 8 with a bracket. And that should, yes. The only other thing I'd point out is, let's just do it as a side over here. Like what if instead I had, when I don't have something just multiplicity 1. Say I have x plus 2 squared, x minus 1, x minus 3 cubed, and let's do less than or equal to 0. So if I go to my number line, I'm going to put 3, 1, -2. Only the -2, where the numerator equals 0, is a filled-in circle. The others are open circles. And let's test. If I put in something greater than 3, everything's positive. 3 comes from this parenthesis grouping with an exponent that is odd, so I'm expecting that to change signs. Same with 1. It's coming from this, an exponent that is odd, changing signs. -2, however, is coming from something raised to an even power, so it shouldn't change signs across that. Now, where it's less than or equal to 0, I'm going to erase this little bit here, which it's not letting me. Okay, so where it's less, maybe I'll do a different color, where it's less than or equal to 0, I see there's only a negative between 1 and 3. However, be careful because this has to be included too. So I'm going to say -2, union 1 to 3. I just wanted to do one that they didn't all have multiplicity 1.